Here we are with Unit 2, page 219 for energy transfer in electrical systems. First, we're going to read about current electricity. So the unit in which charge is measured is coulomb, and 1 coulomb is equal to 6.25 times 10 to 18 electrons. The following is required for a current to flow: a source of electrical energy, a closed circuit, and conductors in a circuit. So conductors are basically just the lines. So the definition of a current electricity is the continuous flow of charge. So current electricity is the continuous flow of charge. Components of electrical circuit. So here we have the name of the component itself, and the symbol that you will use. A connector or a conductor. So this is the component, this is what it looks like, and this is the symbol for it. A cell is a single battery, and this is the symbol for it. So a positive and a negative charge. Don't remember which is which. Battery. A battery is more than one cell. So 1, 2, 3, or more than, or less, maybe 2. So there you can see it is lots of cells in series. Here we have open switch. You can see there the switch is open. A closed switch. The switch is closed. A resistor. And you will just write R in a little block right there. A light bulb. This is a light bulb. Ammeter is with a circle with a little A in it. A voltmeter is a circle with a little V in it. And the minimum components of a circle are, just like we just said, there is a source of energy, like a cell or a battery, a closed circuit, and conductors in the circuit. Connecting wires. It transfers electrical charge over a short or a long distance. A battery are the different cells, and a battery is a combination of more than one cell connected in series. So they're connected, so a cell, lots of cells connected in series is a battery. A switch. When the switch is open, the circuit is incomplete and no current will flow. When the switch is closed, the circuit is complete and the current will flow. An open circuit can be caused by, is the direct oop stroombaan kan veroorsaak word deur, it can be caused by an open switch, a loose contact in the switch, a loose connection somewhere, a broken wire, or even a broken filament in the bulb. So then the bulb would not work as well. Resistors. Resistors is a circuit component that offers resistance against the flow of charge. So it will resist it. Resistors are things like light bulbs, elements in kettles, heaters, geysers, and stoves. So remember, these are all resistors. Exercise 16. This will probably be the questions in your test. Number 1. I will read out the question and then give a little bit of a pause while you give your answer, and then I will give the answer so you can listen if you were correct. Number 1. What are the minimum requirements for a current to flow? An electrical energy source like a cell or a battery, and a closed circuit. Number 2. Complete the following table. So your teacher will probably give you one of these, or one of these, or one of these, and then you have to complete it. So a cell, what symbol does it have? A little long stripe and a little short stripe in a vertical from the circuit. What is the use of it in the circuit? And it's a source of electrical energy. What is a conductor? What is the symbol of a conductor? It's just a straight line. And what does the conductor do? What is its use in the circuit? It connects the circuit components, like a wire. What is the symbol for an open switch? It is this little thingy, which is open. And what is the use of it in its circle? It opens the circuit, so it interrupts the current, so like a light switch that will and that interrupts, that puts it on or off, basically. A bulb. What is the symbol for the bulb? And it's this little thing with a cross in it. And what is the use of the bulb in the circuit? It provides light energy and indicates if the current flows. Number 3, what is a battery? A battery is a combination of more than one cell connected in series. Number 4, give 4 possible reasons why a bulb in a circuit, of which the battery is still fresh, does not glow. There could be a loose contact at the switch, a loose connection somewhere, a broken wire, a broken filament of the bulb, which is very possible, because the battery is fresh but the bulb might not be, or an open switch. You can name any 3 in the question. Any 4, because there's 4 possible reasons. So this is wrong. Don't listen to that. Number 5, what is a resistor? A resistor is a component that resists the flow of a current. Examples of a resistors are a light bulb, an element of a kettle or a geyser, or a stove plate. What are different effects of electrical current? You get a heating effect, a magnetic effect, or a chemical effect. So a heating effect is an electrical current that flows through metal conductors easily. All conductors offer a certain amount of resistance. If the resistance is very high, the current decreases in the circuit. So if the resistance is high, it will not be so warm, right? Because it resists. Examples are heaters, stoves, dryers, copper, and copper has a low resistance, that the resistance is negligible. I can't pronounce that. And fuses are special wires that melt if the circuit overheats. And the circuit is broken because the fuse melts, because there would be no electricity flowing through there. Quick facts. Energy conversion in the resistor is electrical energy to heat energy. Examples. The electrical appliances in which the heating effect of electrical current is applied, for example, stoves, kettles, heaters, irons, geysers, and light bulbs. Because the light bulb gets warm, right? When the electricity flows through it. Exercise 17. Here we go. Question number 1. Name 2 requirements that metals must meet to be suitable as elements. So not elements like on the periodic table. Elements are the things that warm up in an appliance. It must have a high resistance, but it must not melt easily. So it must have a high melting point as well. Name 3 examples of electric appliances in which the element heats up when a current flows through it. That would be a stove, a kettle, a heater, or an iron, or anything else you can think of. No, not that. Number 3. The filament of a light bulb is made of tungsten. When it resists the flow of current, it heats up and then starts to glow. What type of energy transfers occur in the bulb? So electrical energy turns into heat and light energy. Number 4. Explain why a conductor heats up when the current flows through it. So an electrical current transfers electrical energy to the particles of the conductor, and the electrical energy is converted into heat energy. Number 5. The following terms are given: a conductor, resistor, a safety device. Use one of the terms to fit best to the description given. So the description is this. So use the above, conductor, resistor, or safety device. Give the description for an element of an oven. It is a resistor. A blue steel earth wire in a wall socket. That would be the conductor. 5.3. A fuse in a car. A resistor or a safety device, so that it doesn't overheat the circuit. Doesn't overheat. 5.4. An element of a toaster. It's a resistor. 5.5. Copper wire in a computer. It's a conductor. Number 6. Why are fuses used in electrical circuits? I actually just mentioned that. So if it breaks the circuit, if for some reason the current becomes too large, then it prevents people from being shocked and getting hurt, or expensive electrical appliance being damaged, or fires, which is the most important thing for it to stop. Number 7. Name 2 requirements that metals must meet before it can be used as a fuse. And that's an interesting one. A high resistance and a low melting point. So here we have explanation. If a current flows through a conductor, a magnetic field is induced around the conductor. When no current flows, the compass needle returns to the north-south direction. If the direction of the current changes, the direction of the magnetic field also changes. That is the same thing in Afrikaans. 3. Applications. Some examples of application of a magnetic effect are electromagnets, speakers, electric drills, vacuum cleaners, and electric doorbells. How to change an electromagnet into a stronger magnet. You connect more cells in a series in the circuit, make it stronger, place an iron nail in the coil, put more turns around the nail, and use a steel nail instead of an iron nail. It's gonna stop. This is gonna stop now.